So thank you everyone for joining. I'm Ram Lakshmanan. So I'm the architect of the Ycrash product suite. So first of all, I would like to thank each and every one of you for taking your valuable time to attend this Troubleshooting JVM Outages, 3 Fortune 500 case studies, right? So these are the real problems that happened in a very major enterprises. And we are going to debug. And in this session, we're going to see how those enterprises went about troubleshooting these problems, right? Okay. So let's get started. The first case study that we are going to discuss now is, it is a slowdown that happened in a very major financial institution in North America. So it is one of the top 5 financial institutions in North America. So what happened was, this applications, and it was happening in the middleware platform. As a lot of you know, the middleware is a kind of a core or a critical part of any organization. If middleware goes down, right, in the financial institution, the online banking will not work, the mobile banking will not work, the stores, the ATMs, none of them will work. So the middleware's availability has to be 9 fives, right, 99.999%. And this middleware had a problem. That is, what was the problem it was happening? What was the problem it was having? So what happens is, they start the middleware comes up fine. It was taking the transactions, the traffic was going through fine. But all of a sudden, little later, it will start to slow down. It will not respond to the incoming request. And then you have to restart it, right? So this is how they have to do. And they didn't know why. So it was happening across all their JVM deployments, and the JVM was deployed across hundreds of instances, right? So they didn't know why. So they have to be constantly recycling it to make their middleware up and going, right? So let's see how they went about troubleshooting this problem, right? See, friends, whenever this is a production problem, and if it's a performance problem, it is an unknown territory, right? There could be anything could be going wrong. So the best way to solve any such problems in an unknown territory is to equip yourself with enough data, so that you need to have enough data to go about to make a decision to see what's going on. So this organization, they used this open source script called as this YC script, right? So you can trigger this script just like this, YC-P process ID. So when you give this process ID, this is an application process ID, which is in trouble. So when you issue this process ID, and when you trigger the script, this script is going to capture you a 360-degree data from that application stack, right? See, let's see what is the data it's capturing. It's capturing a GC log, thread dump, heap substitute, and also the system level data, like the top, PS, disk usage, and not only the kernel data, the kernel logs, the kernel parameters, application log. It captures the 360-degree data, so that once we have enough data, we can equip ourselves with enough data to make a right decision, right? So they also triggered this on one of the JVM instances. And the data which helped them to rescue the problem is thread dump, right? This is what helped them to save the day. So what is a thread dump? So thread dump is basically a snapshot of all the threads that is running in your JVM. That is, it's a photograph of all the threads that is running in your JVM. It shows where the thread is executing, what code path it is there, what is the thread state it is there. It gives all that information. Friends, whenever there is any problem around the JVM, in 95% or more than 90% of the cases, it will be reflected in the threads. It will be reflected in the threads. So now they took the thread dump. So how does a thread dump look like? So let me just give a quick glimpses of how does a thread dump looks like. So friend, this is how a thread dump looks like. So here on the very top, it shows the timestamp at which the thread dump was captured. The next, it shows the JVM information, whether it was 32-bit JVM or 64-bit JVM, right? It gives those kind of information. And then the next is, say if your application has like 100 threads or 200 threads, for each of the thread, you're going to see the stack trace to be printed, right? So here it is getting printed here. So let's do a deep dive on the thread stack trace. So what is that it contains? So the very first thing, what it's going to be present in the thread stack trace for that segment is thread segment is the name of the thread. So you can see the name of the thread to be printed as invoice thread A996. And then there is a priority. A thread can have a priority anywhere from 1 to 10. So it tells what is the priority of this. And next is the TID. That is, this is a thread ID. See, friend, the first one, what you see is the name of the thread. This is the name of the thread assigned by the developer. That as a developer, I can use the API in Java called as a thread.setName. So when I do that, that is a value it ends up here. A developer can make mistakes. He can give duplicate names for multiple threads. So multiple threads can end up having the same names, right? Whereas here, the TID stands for a thread ID. This is the ID given by the JVM for your thread, and this is always unique. And then the next is NID. This is a native ID. See, what is a thread? A thread at the end of the day is an operating system resource. So operating system tracks all its threads with its own identifying mechanism, and that is reported here as native ID. And then the next is the thread state, what state the thread it is. So, and then the next one is the very important one is the stack trace. This shows the code execution path of this thread. So it says the thread started out here. You have to read it from the bottom. So the thread started here. This is the very first method the thread executed. From here, it went on to execute this method. After that, it went on to execute this method. And then finally, at the time of taking thread time, this is the method it was executing. So it will get to know. And this is all it's there in the thread term, nothing more. Very simple, right? But with this information, you can do really, really wonderful things. You can find out several JVM related performance problems in production environments. So now let's get back to now how do we analyze this thread dump? So you can either open up in the thread text editor and then you can analyze, or you can use these kind of tools which are available to do the analysis. So for now, let's get back to our example, this middleware platform, which had a slowdown all of them out of the blue. It was happening. So now we are going to look at that actual thread dump, which was captured. And now let's analyze it. For our session, I'm going to be analyzing it in this tool called fastThread. Okay. So there is an online edition of it is also available, and it's also there we can also install it locally, right? A lot of organization. This thread dumps is classified as a sensitive information. So you don't want to upload it on the cloud and do the analysis. So you can download it and install it locally, and you can also do the analysis. So now let's upload the actual thread dump of this enterprise, which had the slowdown in the middleware platform. So now I'm uploading the dump. Okay, so it's analyzing. Okay, so instantly you're going to see the result, the analysis result comes up. See, this application, so there are a lot of informations. It gets printed here. Now look at this, friends. At the very top, it shows how many threads are there in this middleware platform. It shows there is like 1,800 threads. So typically this middleware platform has only like 300 or 400 threads. Now it is showing like 4x or 5x more threads are showing up. This itself is a flag, right? It's a warning sign for us. And there is multiple sections here in this analysis report. And there is one interesting section here called as a threads with identical stack trace. So what does this section of the report does is it tries to group the threads which all have the identical stack trace, and then it shows its count. You don't have to use the tool. You can still do it manually. So you can take a thread dump, open it in a text editor, and then you can try to group the threads which all have the identical stack trace and bring up their count. It's a little bit tedious. So the tool does it for you. So it does that. And now when it does it, see here it is reporting there is 1,706 threads. All of them are having identical stack trace. Think about it, when will so many threads will have an identical stack trace? Whenever there is any bottleneck in the application, multiple threads will tend to gravitate there to that bottleneck and they'll get stuck there. If that is the case, all of the threads will end up having the same stack trace. So that's what was going on here. Even though this application has like 1,800 threads, more than 95% of the threads have this identical stack trace. Friends, more than 95% of the threads have identical stack trace. So whenever it sees this kind of a pattern, the tool flags it for you. So here the tool has flagged. Here it says, look at this. It's saying it's flagging as an error. There is 1,700 threads which are stuck waiting for response from this Oracle database. It can slow down the transaction, examine the stack trace. So let's see what is going on. So let me click here to see the stack trace of these 1,700 threads. More than 95% of the threads are having this stack trace. You can see this is the stack trace of the threads. You can see this is originating from this Oracle package, right? See, friends, since this is a middleware platform, this, as you know, middleware platform connects with various system of records. and the tool is one of the top financial institutions. So it connects with multiple system of records. And one of the primary system of record is an Oracle RAC cluster. So the Oracle, the database vendor, told to this middleware platform, to this financial institution, allow financial institution, in your JDBC driver, which you use to connect for the backend Oracle database, set this flag called as ONS, that is online notification service, to be true. So when you set it to true, what's going to happen is, as you know, in the Oracle RAC cluster, there's multi-nodes, there's multiple nodes. If any one node has an outage or it has any problem, the very next transaction will be routed to the other active node in the cluster. So that's what the database vendor told. So this financial institution also enabled the flag to be true. When they enabled to true, the contrary happened to what the database vendor told. What happened was, when they enabled it to true, for any new request that was going to the backend database, to the Oracle RAC cluster, they were creating a new thread. And the thread was never getting terminated. So one request goes, a new thread is created. Another request goes, another thread is getting created. So you can see it's piling up. The threads are starting to pile up. And so you can see it has ended up with like 1,700 threads. When this kind of so much threads create, you end up with your application is going to become unresponsive. So then they took this thread dump and then they showed to the Oracle vendor. Then the database vendor agreed, oh, sorry, there is a problem in the release what we made. So then they patched it and then they gave a new JDBC driver. Once they installed, then the problem went away, right? So friends, one of the primary problem in JVM space or in any application is the backend slowdowns or any backend issues happen is going to reflect on our application. When these kind of problem happens, it's going to be very clearly reflected in the thread dumps. Just take the thread dump, look for patterns. You're going to see it immediately. You're going to immediately nail down the problem, right? Okay. So this is the first case study.